easy. All right, so telescoping series test. I need to turn this into a partial fraction, so it's set up like this one is, with two different fractions and a subtraction sign in the middle, or something like that. So, so here's what we're going to do. I'll write myself a note. Separate the fraction using partial fractions. In other words, you're going to take a over n, remember how this works? A over n plus b over n plus 1 equals 1 over n times n plus 1. And so now we're going to go through and figure this all out, right? Remember how this works. A times n plus 1 plus b times n equals 1. And then you do your ifs, right? If n equals -1, what would that give me? That would zero out the a, so I'd have a negative b equals 1, or b equals -1. The other if statement is if n equals 0, and so that would give me 0 plus 1 is 1, a times 1 is a. It would zero out the b term, and I've got equals 1. All right, so what does that mean? If I go back up here, my a is 1. So let me kind of go back over to my summation thing here. So I've got n equals 1 to infinity, a over n, 1 over n, plus, technically plus, b is -1, so I'm going to make it minus instead, 1 over n plus 1. And there it is. Now I've created the partial fraction that now, let me see if the telescoping is going to work this time. So if I put a 1 in here and start putting in my terms and seeing what happens, if I put a 1 in, 1 over 1 is 1. 1 over 1 plus 1 is 1/2. If I put a 2 in, now I've got a 1/2. If I put a 2 in here, that gives me a 1/3. If I put a 3 in here, now it's a 1/3. Right, and you can see that this is going to continue on and on and on. And my 1/2s cancel, my 1/3s cancel, my 1/4s cancel, and so forth down the line. So this one I can see converges to 1 by the telescoping series test. Converges to 1 by the telescoping series test. All right, so I'm going to give you a chance to try one. If you flip the page, are we good on that one? Holla if I went too fast. So here's the next one, also of the telescoping family here. But this one I have to think about factoring. I have to factor that denominator and see what happens. So this guy would factor into n plus 3 and n plus 1. So you're going to take that and you're going to do your partial fractions with it. And this one's going to be just a tad different, but I'll give you a head start. See if you can find for me what the partial fraction would be. And then figure out the first, I don't know, first 4 groupings, 5 groupings, what that would be. Let's check your partial fraction situation there. So a over n plus 1, b over n plus 3 equals 1. You get a b that's negative 1/2 and an a that's positive 1/2. And so it ends up looking kind of crazy like this. So job number 1 is, did you get the right partial fractions? And the fact that they're like they're 1/2s, that's kind of weird, but it just, you put the 2, the 1/2, the 2 in the denominator. So there's job number 1, is getting the right partial fraction. Job number 2 is then plug in n of 1, n of 2, n of 3, and so forth. And this one's a little different, right? Did you notice? The 1/4, that would be your first term, and then you've got minus a 1/8. Then you have plus a 1/6 minus a 1/10. Then you have plus a 1/8 minus a 1/12. And you see how it's not as consistent as the other ones were? But it still works. It's still, you're still canceling out a positive for a negative of those values. And so what you can't cancel out is this 1/4 and the 1/6. Those are the 2 that stay, they remain. And so your answer is that it converges to whatever 1/4 plus 1/6 is, and that would be 5/12. So this one, and I didn't say it here, but I will now, converges to 5/12 by the telescoping series test. So they don't have to be directly next to one another, like 1/6, 1/6. You know, they can be down the line a little bit further, but they still would cancel out a positive for a negative.